Hello friends, in our earlier videos, we understood the remainder theorem and the factor theorem. Today, let's solve some problems related to both those theorems. Before that, let's revise the theorems very quickly. The remainder theorem states that if p of x is any polynomial of degree greater than or equal to 1 and a is any real number, if p of x is divided by the linear polynomial x minus a, then the remainder is p of a. On the other hand, factor theorem states that if p of x is any polynomial of degree greater than or equal to 1 and a being any real number, x minus a is a factor of the polynomial p of x if and only if p of a is equal to 0. So let's start doing problems. Here is our first question. In this problem, we have to find the remainder when the polynomial f of p is divided by the linear polynomial 2p minus 7. Now, this is the type of question where we can usually use the remainder theorem. But the divisor is 2p minus 7, which is not exactly in x minus a form. So, what do we do now? Let's say q of p is the quotient and r is the remainder when the polynomial f of p is divided by the linear polynomial 2p minus 7. So we can express the polynomial f of p as the product of 2p minus 7 and q of p plus the remainder r. Now if you remember, in remainder theorem, to find the remainder we substituted a in place of x. So our main aim was to make the divisor term 0 so that we can find the remainder. Now coming to our problem, to find the remainder, we have to make the divisor equal to 0. So let's equate 2p minus 7 to 0. And doing so, we will get p equal to 7 by 2. Now, if we substitute p equal to 7 by 2 in this equation, we will get f of 7 by 2 equals to r. So, the remainder is f of 7 by 2 and we can find f of 7 by 2 by simply substituting 7 by 2 in place of p in the polynomial f of p. So, if we substitute 7 by 2 in place of p and if we find f of 7 by 2, we get f of 7 by 2 equal to 10. So, therefore, we can conclude that when the polynomial f of p is divided by the linear polynomial 2p minus 7, the remainder is 10. The most important step in solving such problems is finding the 0 of the divisor polynomial and using that 0 to find the remainder of the polynomial when divided by the divisor. Now, let's move on to our next question. In this problem, it has been given that both 2x plus 3 and x plus 2 are the factors of the polynomial g of x. And we have been asked to find the values of a and b in the polynomial g of x. If you remember, we solved a similar problem in our previous video using the factor theorem. So we will use the factor theorem in solving this problem as well. The factor theorem states that if p of x is a polynomial of degree greater than or equal to 1 and a is any real number, x minus a is a factor of the polynomial p of x if p of a is equal to 0. And if p of a is equal to 0, then x minus a is a factor of the polynomial p of x. But here we have been given two factors. So let's take each of them individually and apply factor theorem. As x plus 2 is a factor of the polynomial g of x, g of minus 2 must be equal to 0 since x plus 2 is nothing but x minus of minus 2. So let's equate g of minus 2 to 0. If we substitute minus 2 in place of x in the polynomial g of x and find g of minus 2, we will get it as minus 16 plus 4a minus 54 plus b. Since g of minus 2 must be equal to 0, we will equate this expression to 0 and finally we will get 4a plus b equals to 70. Now, in the same way, we will make use of another factor to find another equation in terms of a and b. But this factor 2x plus 3 is not exactly in the form of x minus a. So, what do we do now? We will follow the same approach that we followed in our first problem. So, in the first problem, we made the divisor term equal to 0. So, similarly, we will make the divisor term 2x plus 3 equal to 0, which will give us x equals to minus 3 by 2. So, if we substitute x equals to minus 3 by 2, we will get g of minus 3 by 2 and it should be equal to 0 since 2x plus 3 is a factor of the polynomial g of x. Now let's find the value of g of minus 3 by 2. G of minus 3 by 2 will be equal to minus 27 by 4 plus 9a by 4 minus 81 by 2 plus b. If we simplify this and if we equate g of minus 3 by 2 to 0, we finally get 9a plus 4b equals to 189. So, here we have two equations in terms of a and b and we have to find the values of a and b. The two equations are 4a plus b equals to 70 and 9a plus 4b equals to 189. We will multiply the first equation by 4 and then subtract the second equation from the first equation. Doing so, we will get 7a equals to 91, which implies that a is equal to 13. Now substituting a is equal to 13 in the first equation, we will get the value of b equal to 18. So therefore, the values of a and b are 13 and 18 respectively. So this is how the factor theorem helped us in finding the coefficient of x squared and the constant term in the polynomial g of x. So friends, I hope you understood how to solve problems with the help of the remainder theorem and the factor theorem. Just do not remember the theorems. Try to understand their actual meanings so that you would be able to solve any difficult problem. So, keep practicing and stay tuned.